In our third module of SRTV, we're going to be looking at hydrology, or the way that water behaves, in the context of doing vehicle rescues from swiftwater incidents. Thinking back to our stability chart, we know that as the velocity and the depth of water increases, so does the instability of the vehicle. For most vehicles being with the engine in the front, this means that the engine block area is the last to keep contact with the ground, which creates a pivot point. On this basis, it means that in most cases, vehicles will present in an engine upstream orientation. With this engine upstream orientation, the vehicle creates a upstream V. This in effect creates an eddy downstream of the vehicle. And a cushion wave, also known as a buffer wave, is created across the windshield. Depending on the bottom type, whether it's soft or hard, that may also create a siphon at the front of the vehicle. You can also see in this photograph that a very distinctive eddy line, or the separation between the eddy and the flow. From another perspective, you can see the cushion wave being rather distinct on the windscreen. You can also see from the side that there's quite a big depression that's created from the upstream V and the creation of the eddy and the eddy line. So even though there's quite a high flow over the windscreen, you can see where the door is that there's actually a little bit of space there where the door can be potentially opened. We have four forces acting on the vehicle. We have the weight of the vehicle pulling downwards, we have the buoyancy of the vehicle pushing upwards, and then we also have from the sides the friction force of the ground and also the flow force of the water. Once these forces are equal, the vehicle is in equilibrium and it's stable until another force acts upon it, which within swiftwater can happen with the surging of the water, or a change in the friction, or even a change in the buoyancy of the vehicle. So let's look in detail what are some of the variables on those four forces that interact on the vehicle in water. Where a vehicle does present side on to the flow or is pushed into this position, the stability becomes even more critical. On hard ground, the vehicle was more likely to roll. When it's in soft ground, it's likely to bed down and become more stable. So, if you've got a vehicle that's got flow coming side on, as depicted here, what instructions can you give? Remember our low to high risk methods, YOW. YOW. We can give instructions for the occupants to high side. So to prevent the vehicle from flipping over, the occupants of the vehicle, if they're unable to get out of the vehicle, could try to move their weight to the upstream side of the vehicle to prevent it from rolling over. This is known as a high side. In addition to this, naturally we want to give instructions as part of our YOW and our initial arrival actions, making sure that we tell people to take their seatbelts off, open up the windows, break the glass, and they can also leave the lights on, especially at night time. That means if the vehicle moves, it will be easier to locate the vehicle downstream. Vehicles in soft ground can actually be very stable, to the point that it becomes very difficult to extricate the vehicle later on. The vehicle often will bed down in sand, mud, or even shingle, to the chassis. And as it beds down, it actually eliminates or reduces the gap between the chassis and the ground, and as a result, that can mitigate the siphon risk. Vehicle behaviour is also affected in terms of its loading. Top loads are generally boats such as sleds, rafts and kayaks. Just below the surface is where the water flows the fastest, as there is less air friction pressing down onto the flow. This is also why when you tie a rope to a person, once they enter the flow, they'll be pulled under into the fastest flow. Suspended loads are below the surface in their entirety and may travel faster downstream until they go below the peak of the fast flow and slow down until they rest on the bottom of the river or channel, where due to surface friction, the flow stops. This is also how divers can access waterfalls, as they can dive downstream, get to the bottom of the river, and then just pull their way upstream using the floor of the river. If you're carrying out flood rescues or evacuations, chances are you'll need to ensure that you have the capability to rescue animals. This is because people often refuse to evacuate unless their pets can come at the same time, and if they are left behind, owners often legally re-enter later to rescue them, which puts their and the safety of public safety workers at risk. If you'd like to know more about animal emergency management, go to our course on Animal Emergency Management Fundamentals. In the meantime, let's look at some simple tips. In your team cache, you should have a range of dog PFDs and also a small range of basket type muzzles as seen on the slide here. Making sure you've got medium and larger size PFDs means that you can fit those to the animal, and it makes managing them in water a lot easier. Because if you grab around the collar, the dog may feel it is choking and react in a negative way towards you. As you can see on the previous slide, carrying a dog in water, once the muzzle was placed on the dog, then you can put an arm underneath around its tummy, and then the other arm around its neck, so you can control the head and ensure that the head is kept out of the water. For small companion animals such as small dogs, cats, rabbits, etc., place them into a cage. If there's any risk that they may be submerged, you can put that cage into a watertight pelican case or dry bag for supervised short periods only. In regards to using a muzzle, you may need to be aware that there are regulations in terms of the use of muzzles under the animal welfare regulations in New Zealand. Speak to your veterinarian or animal welfare inspector for further information. If you are conducting training, do not use live dogs for swiftwater training. Use a mannequin.